Hey guys, in this video we'll be discussing the speed time graph. We'll be looking at how to plot a speed time graph, what the gradient represents, and also what the area under the graph represents. So stay tuned. Before we plot the graph, the first thing we need to know is how to take down values of speed against time. The first step to plotting of a graph is always to draw the table. So we have to collect our information and represent it in the form of a table. This is the best way to have all the data that we need before we plot the graph. So let's look at how to take down values of speed against time. So let's look at the motion of this car. So at 0 seconds at the start of the journey, the car is at A and it is not moving. So the speed here is 0. So at time 0 we write speed equals to 0. And then at 2 seconds, the car has started moving and is moving at a speed of 10 meters per second. So at 2 seconds, the speed is 10 meters per second. So notice this, the speed that we record is the speed at that specific time. So for example here, at 2 seconds, the car is moving with a speed of 10 meters per second. At that specific time, the car is moving at a certain speed. This is how we record the data. So at 4 seconds, the car is still moving at 10 meters per second. Notice that it has gone forward. However, it is moving at the same speed. We are not concerned with the distance here. We are only concerned with the speed and the time. So at 4 seconds, the car is moving at 10 meters per second, and that is what we record. 4 seconds, 10 meters per second. And then 6 seconds, it moved further forward, but it's still moving at the same speed, 10 meters per second. So 6 seconds, 10 meters per second. And then at 8 seconds, the car has come to a stop at point B. So here the speed is 0. And so we record at 8 seconds, the speed equals to 0. Now we have all the data of all our times and the speed at that specific time. So now we have our table. It's time to plot the graph. So let's look at how to plot the graph. Now normally we plot the graph directly from our table. But here I just want you to compare the motion of the car directly with the graph. So again, at the beginning, at 0 seconds, the car is not moving, so the speed is 0. And so we plot the first point. At 0 seconds, the speed is 0. At 2 seconds, the speed is 10 meters per second. The car has started moving, and at 2 seconds, the speed is 10 meters per second. So 2 seconds, 10 meters per second. This is the second point. And at 4 seconds, the speed is 10 meters per second. At 6 seconds, the speed is 10 meters per second. I want you to notice that the speed did not change from 2 to 6 seconds. The speed has remained at 10 meters per second. So that is how you look at it when you look at the graph. The time is moving forward, but the speed is not changing. And then at 8 seconds, it is not moving. Speed is 0. And so the speed drops down to 0. So this is how we plot a speed time graph. The speed is always on the y-axis and the time is always on the x-axis. So the next question is, what does the gradient of a speed time graph give us? The gradient of a speed time graph will give us acceleration. Let's look at how to find the gradient. So in order to find the gradient of any graph, we always take the change in y over the change in x. That means y2 minus y1 over x2 minus x1. So here when we are taking the change in y, for speed time graph, the y-axis represents speed. So what we are actually measuring is the change in speed over, and the x, the change of x means the change in time. So the change of speed over time, this is the definition for acceleration. So when we find the gradient of a speed time graph, we will get acceleration. Now let's look at this example. Let's look at the first instance of motion from 0 to 2 seconds. So if we wanted to find the acceleration from 0 to 2 seconds, then we need to find the gradient of the graph from 0 to 2 seconds. So here, let's just look at the speed values. The car is moving from 0, that means from completely not moving, 0 meters per second, and the speed is going to 10 meters per second. So we know here that the speed is increasing. When the speed is increasing, then we know that there is a positive acceleration. So a positive gradient, a positive slope will give us acceleration. That means the car is moving faster and faster. The speed is increasing. Now, how do we find the value of acceleration here? We need to find the gradient. And so we get y2 minus y1. So y2 is 10, y1 is 0, 10 minus 0 over x2 minus x1. So we have 2 minus 0. So this is how we get the value for the gradient here. And we will get 10 over 2, which is 5 meter per second squared. This is the unit, because the speed here is meter per second and the time is second. So our unit for acceleration is meter per second squared. So this is the acceleration of the car from 0 to 2 seconds. So one slope, this is the same slope all the way, the same gradient all the way. So it is a constant acceleration. The acceleration doesn't change at 5 meters per second square from 0 to 2 seconds. Let's look at the next part of the motion. What does this horizontal line mean? The concept is the same. Acceleration is found by the gradient of the graph, by finding the gradient of the graph. And for a horizontal line, the gradient is 0. So if the gradient of a horizontal line is 0, it means that the acceleration is also 0, because the acceleration is given to us by the gradient of the graph. So if we have 0 acceleration, if we have no acceleration, that would mean that the speed is the same. The speed is constant. It didn't change. So here, let's try to find the gradient. So the gradient will be y2 minus y1. So we are looking at this gradient here. So I'm taking the point at 6 seconds and at 2 seconds. So this is, the speed is 10. The speed here is also 10. So it's 10 minus 10 over x2 is 6 and x1 is 2. So 6 minus 2. And so we would get 0 over 4. 0 divided by any number will still give us 0. So the acceleration here is indeed 0 meters per second squared. There is no acceleration because the speed is 10 meters per second all the way. There has been no increase or decrease in speed. That means the acceleration is 0. How about if we have a negative gradient then? A negative gradient, let's look at this motion here. So at 6 seconds, the car is moving at 10 meters per second. However, 2 seconds later, the car is not moving anymore. So the only logical reason here is that the car is slowing down. And so whenever we have a negative slope, when we have a negative gradient, it means that the car is slowing down. The object is slowing down. And a motion where an object is slowing down is known as deceleration or negative acceleration. It means the same thing. So it basically means the object is slowing down. So how do we calculate the acceleration or deceleration here? So here we calculate the acceleration first because the gradient directly gives us the acceleration. So let's try to calculate the gradient here. So this is y2 and this is y1. So it will be 0 minus 10, 0 minus 10, and then x2 minus x1, 8 minus 6. So we have negative 10 over 2, which is negative 5 meter per second squared. So the acceleration here is negative. If the question asks you what is the acceleration of the object, the answer is negative 5 meter per second squared. However, if the question asks you what is the deceleration of the object, then the deceleration of the object is positive 5 meters per second squared. When they ask you for acceleration, the answer is negative. But if they ask you for deceleration, then the answer is positive for an object that is slowing down. So this is what the gradient of the graph gives us. Positive gradient will give us acceleration. When it is a horizontal line, 0 acceleration, which means the object is moving at constant or uniform speed. And when it's a negative gradient, then it is negative acceleration or deceleration. The object is slowing down. So that's it about the gradient. Now, what would the area under the graph give us? So first of all, what is the area under the graph? What does it mean? The area under the graph is the area enclosed by the region between the graph and the x-axis. How do we find the area under the graph from 0 to 2 seconds? So we do that by finding the area of the shape that is formed. So if it is a geometrical shape, it's very easy to form. It's very easy to calculate. So here, if we find this area of the shape, we can get the area under the graph. The area under the graph for a speed time graph will give us distance. So let's say we wanted to calculate the distance from 0 to 2 seconds. So since this is a speed time graph, in order to calculate the distance, we need to find the area under the graph. So this shape here is a triangle. So if I wanted to find the distance from 0 to 2 seconds, I need to find the area of the triangle here, this blue triangle. So the area of the triangle is of course half times base times height. And so we put in the values of the base and the height. The base from 0 to 2 is 2 units, and then the height is 0 to 10. So it is 10 units. So half times 2 times 10 will give us 10 meters. Now here the unit is meters because the speed is in meters per second and the time is second. And so the unit is in meters. How about if I wanted to find the distance from 2 to 6 seconds? So if I wanted to find the distance in a speed time graph, again we have to use the area under the graph. So the area, this shape here is a rectangle. The reason I say rectangle is because the scale is different. This is 2 units and this is 5 units. So if we wanted to get the area of this shape, we take the length multiply by the width. So what we get here is 10 from 0 to 10. This is 10 units and this is from 2 to 6, which is 4 units. So 10 multiplied by 4, we get 40 meters. 40 meters is the distance traveled by the object from 2 to 6 seconds. And then if we wanted to find from 6 to 8 seconds, it's the same process as 0 to 2 seconds. We find the area of the triangle here. Now what if we wanted to find the total area? If the question asks you what is the total distance traveled by the object, so the total distance will be the whole area under the graph. And this shape here, if you're not sure, then you can separate it into 2 triangles and a rectangle in the middle. However, this is a trapezium, and we can find the area under the graph by directly calculating the area of the trapezium. So the area of the trapezium will be half multiplied by the sum of the parallel sides and multiplied by the height. So here we have half times, this is from 6 to 2, so 4 units, and this is from 8 to 0, 8 units. So half times 4 plus 8 multiplied by the height. The height here is 10 units, so times 10. So this will be 12 times 10 divided by 2, which gives us 60 meters. 60 meters is the total area under the graph. Can you guess what the area under the graph for a velocity time graph will give us? So that's all for today, guys. I hope you've learned something. If you have, please hit the like button, and if you haven't subscribed, please subscribe. I'll see you in the next video.